Yeah, hello. Myself Amit Ranjan. Today we are going to discuss about the application of derivatives. Okay. In this topic, I am going to explain maxima and the minima. Okay. First of all, I will tell you what is the importance of maxima and minima. It means what is the applications of maxima and minima. Okay. See, in businesses, every businessman wants what maximum profit, and when we are just buying something, it means like minimum expenditure or something. In functions, if I am taking one example of the functions, and we also want at what values and the function will change. Okay, see, now I'm going to explain with the graph. Okay, now I am taking one graph. Here I am taking this value is a, here the value is b. If you look at the top, or you can say also the peak value of these functions, that is what this value here, and I am taking this value as t. Okay, now this is what the peak value, it means the maximum value of these functions. But how you understand this is the maximum value? Listen, if you look at the just left side of this specific point c, it means this side. Here the slope, it means dy over dx, that is greater than 0. And when you look at the point, a specific point c, the just the right side, that is what dy over dx, that is slope is what less than 0. It means we can say na, slope changes from positive to negative. Okay, it means then what we can say, this is our maxima, this is our maxima. Okay, now I am taking another graph here, please be careful. Okay, this graph, this value is a, let us assume this is what B. Here this is what c. Okay, now when you look at the this point, it means this is what we can also say the horizontal tangent line at c, and this is also look like a valley, look like a valley. Okay, and when you look at the just left side of this specific point c, that is here, the slope is what decreasing, it means dy over dx, that is less than 0. And when you look at the specific point c, just right side, here the slope dy over dx, that is greater than 0. Okay, so in this graph we can understand now the slope changes from negative to positive. Let me just write, slope changes from negative to positive. Okay, what is the meaning of these things? It means the graph has a what, minima. Okay, or you can also say this function has a minima. Okay, now I hope you understand what is the minima, what is the maxima. Okay, now, okay, now I'm going to take there are two ways to find minima and maxima of any functions. Okay, see, two ways. The first is what, first order derivative test, first order derivative test. Okay, the second one is what, second order derivative test, second order derivative test. Okay, now I'm going to explain what is the meaning of first order derivative test. Okay, because we are doing application of derivative. Okay, we must have to solve the questions using derivative or the differentiation. Okay, now I'm assuming any functions is given, f of x is given, then we must have to find the derivative f dash x. Okay, we can find, then you just have to put f dash of x, that is equals to 0. Okay, and we got some values. I'm assuming there are two values. Okay, and what is this thing? This is critical points. This c1 and c2 is what? Critical points. Okay, now but how can we understand at which values of x or what values of x the value is maxima or the minima? Okay, see, just write here c1 and c2. Okay, now take the less value than c1. Here I am assuming, here when we put this value in f dash x, we got positive. In between c1 and c2 it gets negative, here positive. Okay, I am assuming like that. See, here if you see, the slope is what changes from positive to negative. It means this point c1 is known as point of maxima. Okay, now if you look at the c2, here the sign changes from negative to positive. This is known as point of minima. Okay, and when you put this value c1, when I am putting this value in the functions f of c1, what is f of c1? F of c1, because c1 is the point of maxima, and when we put c1 in the functions, it means we got maximum value. Okay, and when we put the value of c2 in these functions, that value is what? Minimum value. Okay, because c2 is what? The point of minima. Okay, now I'm going to take one examples and I will show you how to get maxima and the minima, maximum or the minimum value. Okay, I'm taking one examples like f of x is equals to x minus 1 times x plus 2 square. Okay, now what we have to find? We have to find maxima, minima, okay, and also maximum value and minimum value. Okay, now let's solve these things. For doing that, finding the differentiation, just solve these things. X minus 1 times, what's the a plus b whole square? X square plus 4 plus multiplication is what? Times x cube or x square plus 4. Okay, x square 4x minus, if you look at here, plus 4x minus 4x cancel out. Okay, it means what we got it, x cube plus 3x square. Okay, this is our f of x. Now Just find f dash x. F dash x is equals to what? 3x squared plus 6. Okay. Now then what you have to put the value f dash x is equals to 0. Then it becomes 3x squared plus 6x, that is equals to 0. When we got let's take common 2, that equals to 0. It means what we got, the value x is equals to 0 or negative. Okay. Now, but how can we understand at what value of x the function is minima or the max? Okay. See, I am plotting here a line. I am taking the value -2 here and here is 0. Okay. See, just think the less value than -2, that is -3. Put here f dash of -3 is equals to what? F dash is how much? 3x, no? 3 times -3 is -3 of the square is 6 times of minus is equals to 7 minus equals to 9. It means positive value. Here what we got? Positive value. Now in between -2 and 0, I'm taking 1. F dash of 1, that is equals to what? 3 times of 1 square plus 6 times of 1, that is what? 3 plus 6, that is 9. It means f dash 1 here I am taking this as a positive, here positive. Okay. Now let's take one value in between -2 and 0, that is what? -1. Let's find f dash of -1, that is equals to what? 3 times -1 square plus 6 times of minus, that is what? 3 minus 6, that is equals to -3. Here we got negative. Okay. If you look at here, please look at here. Here I am just circling these things. Here the sign changes from positive to negative. Okay. Now I am erasing these things. See. At x equals to -2, here the sign changes from positive to negative. It means -2 is known as point of maxima. Okay. And when you look at the 0, here the sign changes from negative to positive, that is, this is known as point of minima. Okay. Now but we got the maxima and the minima. Now what we have to find out? We have to find the maximum value and the minimum value. Okay. See, now what I am going to do, just put the value f of -2 into these functions. Okay. Let's find value -2 of -1 times that is 0, -2 -2 and +2 all becomes 0. Okay. And when you put the value of f of 0, that is equals to what? 0 minus 1 times 0 plus 2 square. Now this is what? -1 times 4, that is equals to what? -4. Now it means at x equals to -2, the value is what? 0. This is what? Maximum value. This value is known as maximum value. Okay. What about 4? 4 is minimum value. I hope you understand these questions, how to find the maxima and the minima. Okay. Now the next thing, now I am going to discuss about the second method. Okay, that is what? Second order derivative test. What was that? Second order derivative test. See, now here in these functions or in this test, what we have to do? Let us assume any function is given. F of x is given. Let's find the first derivative f dash x. Okay, then the same thing you did in first order derivative na. F dash of x, that is equals to 0. You got some values. X, you got, let us c1, c2. Okay, now what you have to do? Then find the f double dash of x. It means second derivative of that functions. Okay, you got some values. Okay, you got some values. Then when we put the value of f double dash c1, let us assume this value is what? Less than 0. Okay, and then we can say na, the c1 is what? Point of maxima. When we put f double dash of c2 is greater than 0, then we can say point of okay. And one more thing, we can also write f double dash of c, that is equals to 0. Okay, it means that is known as what? If double derivative value is 0, then we can take what? Point of inflection. This point is known as point of inflection. Okay, now I am taking that same examples. Okay, I'm taking the same examples and I will try to show you how to solve using this second order derivative test and the of x equals to x times. I'm taking that function's value. Okay, x cube plus 3x square minus. Okay, this is our functions. Okay, now do the same thing. F dash of x, find the derivative, first derivative, that is what? 3x square plus. Okay, do the same thing. F dash of x is equals to 0. It means 3x square plus 6x is equals to 0. We can take common here, 3x times x plus 2 is equals to 0. Therefore x is equals to what? 0 comma minus. Okay, we got two critical points. Then do the second derivative. Okay, find the second derivative of the same functions f double dash x. Okay, what is it? When you solve, it becomes 6x plus 6. Okay, now what we have to do? Just put the value here, f double dash 0, and find f double dash of minus 2. Okay, then find this value. F double dash 0 is what? When we put, we got 6, that is what? Greater than 0. Okay, and when we put the value of minus 2, it becomes minus 12 plus 6, that is minus 6. It is less than 0. Okay, when the double derivative is greater than 0, it means that is known as point of minima. point of minimum. And when we put when we got f double dash of c value is less than 0, that is point of. Okay, and when we put this value in the functions, we got the maximum value or the minimum value. Let's put f of 0. F of 0 is what? Point of minima. Let's find put this value f of 0, that is what? 0 plus of, this is also 0, 3 times 0 minus 4, that equals to minus 4. Okay, when you find f of minus 2, f of minus 2, it becomes what? Minus 2 of cube plus 3 times minus 2 square is 4. Solve this. This is minus 8, or this is plus 4 3s are 12, so is minus. Okay. It means 0. See, now you understand now which value is the minimum and which one is the maximum. When put when the value of x equals to 0, that is what? Point of minima. And x equals to what? Minus 2, that is point of maxima. When we put this value in the functions 0, that is known as what? The minimum value. This is what? The minimum value. Okay, and what this is? The maximum value. Okay, understand? I hope you understand these things. Now, then one more topic in these things, that is what? Absolute maxima and the absolute minima. Okay, see, let us try to understand what is the meaning of these things. It means, okay, I'm drawing some graph. Okay, see, when you look at between from here to here, look in between from, this is 0, a, b, I'm randomly writing any values. Okay, if you look at between 0 and a, okay, whatever the maximum value, here is the maximum value. When you look at between a to b, here is the value, here is the value. Okay, it means what's the maximum value in between some intervals, like in any specific area na, there is a one leaders like something. Okay, see, it means when we are going to find the absolute maximum, absolute minima, it represents what? We have to find the value in between close intervals, in between close intervals. Okay, now I'm going to take one examples. Okay, and I will show you how to do this. Okay, it's very simple comparison to the first order and the second order derivative. Okay, see, okay, just look at the questions. Okay, now this question is what? If you see here, there is here is the closed interval. Okay, it means we have to find the absolute maximum value and the absolute minimum value in between -2 to 9/2. Okay, see what I'm going to do here. Let's do f dash x, that is equals to what? Tell me. 4 minus it becomes 1/2 times of 2x. Okay, 2x, 2 cancel out, then we got 4 minus x. Okay, then what we have to do? F dash x equals to 0. That is what 4 minus x is equals to what? 0. Therefore, x is equals to 4. Okay, so this is our critical points. Only one critical points. Okay, and then next step, what we have to do, just put the value f of negative 2, find this value, f of 4, find this value, or f of 9 over 2. Okay, just find this value, and you can compare which value is the minimum, which value is the maximum. Okay, see, 4 times minus 2 minus 1 over 2 minus 2. You solve, it becomes minus 8. Here is what? Minus of 2. Okay, 1 over 2 times 4. Cancel out 2 to 4. Okay, and sign is minus. That is, we got minus 10. When we put the value of x equals to 4, how much we got it? 4 times of 4 minus 1 over 2 times 4 square. Okay, right, this is 16 minus 1 over 2 times 16, it becomes 8. 16 minus 8, that is 8. Okay, and when you put the value of f of 9 over 2, that is 4 times 9 over 2 minus 1 over 2 times 9 over 2 square. Okay, when you find 2 ones are 2, 4 here. Okay, that value is what? 9 2s are 18 minus 8 becomes 81 over 8. 81 over 8. Okay, just also find this value, take LCM 8. 18 8s are 144 minus 81, that is equals to what? 144 minus, let's do the 3 and 6 over 8. Almost what? 6 point something, na? No, almost value we can take 8. Almost we can take value 8. Okay, almost. Now, when you put this value, see, what about this value and what about this value? Okay, here is almost 8. Here also we got almost 8. Okay, it means we can compare which value is the minimum value and which value is the maximum value. Okay, it means minus 10 is what? That is the absolute minimum value. Okay, and what about 8? This is what? Absolute maximum value. Okay, I hope you understand all the things, like we did maxima minima, first order derivative test, second order derivative test, and then last absolute maximum value and the absolute minimum. Okay, thank you.